All right, so this is the review for the quiz. We are starting on worksheet 9.5. We decided to eliminate T first, so we did that down here. And now we're working on graphing this, and I forgot to start the recording. Sorry, guys. All right, what goes in the T table? Perfect. -2, -1, 0, 1, and 2. Okay. Now, we could find them by hand. How do we find the x's? 3 times t minus 2. Now, I tell you what I did. I found these values, and then I plotted those. This says x, and this is y. That's not how we do it, right? I messed up on mine. We need to find the y values then by taking the t's and squaring them and adding 4, and then we're going to plot these. Okay? Can we just do it on the calculator to save time and energy? Yep. You can do it that way on the quiz as well. So notice this question does not have a sine or cosine, so it doesn't matter if you're in degrees or radians for this question, okay? Only matters when you're pushing sine or cosine. So we're going to go to mode and make sure we're in parametric. Not polar, not function, but parametric. And then when we go to y equals, we're going to put in the two equations, 3t minus 2. And what was the other one? T squared plus 4. Okay. And I'm going to set my window up to be, was it -2 to 2 for the t by 0.1 and -10 to 10 and -10 to 10 for the x and the y. Or you could just do a zoom standard and then go back in and change your t. You just have to set the t. If I graph it, I get this. Anybody having trouble? Okay. I can look at the table for those values now. Just make sure you start at -2, right? So we had -8, 8. And then it ended, to +2 at 4, 8. I'm just going to do this. All right, so if I graph those, I had the endpoints were at -8, 8. And the other one is at 4, 8. And those always occur when t is at the ends, and you don't have to write that part down if you don't want to. All right, then it went to -5, 5, -2, 4, 1, 5, 4, 8. Okay. Anybody's look roughly like this? Anybody remember the other thing we're supposed to indicate? And I'm not sure I can really grade on this because I don't think I put a reminder on the quiz. You're supposed to indicate orientation. Do you remember what that meant?
Right.
Okay. It means as you go from -2 to 2, it was going this way. What you don't want to do is put arrows on the ends because it doesn't continue, right? It ends. So those arrows are indicating orientation. I would like you to do that on the quiz. If you don't, I'll probably put it on there for you as a reminder, but honestly, I don't think I put like in the directions indicate orientation. So I'm afraid we're going to forget. Any other questions about that one? Okay, we're still on this learning target because we have an application. Okay, what mode do we have to be in for this number 2? What's this telling us? Yes. This quiz, you're going to have to switch back and forth or it's going to mess you up so bad. So, no, the first one, it didn't matter. So you could have been in degrees from the beginning. So it's okay if you put the whole parametric section in degrees. Okay. Now, what are we going to put in here? Does anybody remember? It's on the pink sheet. What are the equations on the pink sheet? Ava kicked a soccer ball, initial velocity of 40 feet per second, an angle of 33 degrees with the horizontal. We're going to assume it's on the ground. After 0.9 seconds, how far has the ball traveled horizontally? T, V sub 0. What is V sub 0 here? Which is 40, okay, times cosine of the angle, which in this case is 33 degrees. And then the equation for y is the same, but with sine. And then it's minus 16t squared, and there's no initial height. What's an appropriate window? And I want an appropriate window, guys, not just any old thing. How long can it take a soccer ball to come down? Do we need 0 to 100? Or negative 5 to 5? No, we can't have negative time. And I don't know, I'm going to put 5 seconds. I'm sure that's enough. Okay, x is what? What is x representing here? How far horizontally? Very good. So 0 to, I have no idea. Maybe, oh, I was going to start with like 100. You want to put 50 and see what happens? We can change it, right? And the height is this. And so 0 to, I don't know, I'm going to try 20. All right, so make sure you're in degrees in parametrics. And then we had T, was it 40 cosine 33? And then T 40 sine 33, close parenthesis, minus, Keaton's not here, did you want this back? Minus 16t squared. Thanks. We said our window was 0 to 5. Then I had 0 to 50 and 0 to 20. Is that what I put, guys? Okay, how'd we do? Ooh, not bad. We didn't need the 20 up, but it'll work. Whose is not working? Everybody got it? Higher? Did you remember to close this parenthesis? Here's my window again. Point, well, it doesn't matter. It's fine even if it was. Tristan, this is for you. It said at 9:30, but that's like past already. I don't know. I would just say go at the end of the hour unless you want to miss a review for the quiz. Did you get it to work? Okay. The question on the quiz says, what is the horizontal distance traveled after 0.9 seconds? Do you see that up here, guys? So if we go out to exactly 0.9, so we can trace or just type in a value at 0.9, how far horizontally has the ball traveled? Yes, 30.2. What if it asks how long till the ball landed? Yes, and we'd have to figure out roughly close as we can get here to 0. There's a nice negative 0.8, and it took about 1.4 seconds. Or we could say it was almost 47 feet away, right? All kinds of different things it could ask. Any questions about that? Okay. What do you think is going to be the biggest mistake you're going to make on that section? Maybe remembering degrees. That would be my concern as well. All right. Next question. Warning. Anybody remember how to do these? They're not hard, and it's a multiple choice question, so I hope it'll serve as a reminder. But is there anybody who remembers how we did these to get rid of theta? Oh. Should be the second day we did this stuff. So if you go back in your notes packet to x equals, and it's 3 cosine t really, but it doesn't matter. I don't want to waste too much time. If you divide by 3 here, and you divide by the 5 here, then what did we do? That helping anybody remember? Squared both, okay? So if I square both sides here, and then I'll get a cosine squared, and I squared both sides here, and I get a sine squared. Why did that help us? Because if we added this side together, we got equals 1. And over here, we ended up with x squared over 9 and y squared over 25. Is everybody okay? It's a hyperellipse. Just kidding. It's an ellipse. You don't have to know that. It's going to be multiple choice, and the equations are going to be there, okay? But don't be surprised if one of them, like, if this didn't have the 3, you would just have x squared equals cosine squared, right? And this one you would still have to divide. So here at the end, you would have just had this or whatever, okay? Any questions on those? Seem like we can do that, especially if it's multiple choice, so it reminds us how we did it. All right. There's more practice on that on the bottom of 9.5. You can do it all over again tonight for practice at the bottom of 9.5. And the key to that is posted in Google Classroom, okay? All right, then moving on to the second learning target is vectors. It says you have to be able to sketch it, find either the horizontal or vertical, and be clear on which one it's asking for. Then find magnitude and direction, and basic operations. All right, so there's an example here right on the review. It says sketch and find the vertical component of V if it has a magnitude of 8 centimeters with an angle of 55 degrees. So I would just expect you to go roughly, here's 55 degrees, and label this. If you remember to put the little at the end to show it's a vector, it's okay. I wouldn't count it wrong if you didn't. And it's 8 centimeters long. There's the sketch part. We good? Then how do we find the vertical or horizontal? One version says vertical, one says horizontal. Anybody remember? How do we find component form? R cosine theta, R sine theta. Does that sound familiar? We did this yesterday with polars as well. So R cosine theta, R sine theta. What mode should we be in? I think this whole section is still in degrees, okay? Which one is going to be vertical though? Yeah, this would be horizontal, right? X goes across. Y would be the vertical. So for this particular one, we just need 8 sine of 55 degrees. So we're still in degrees. 8 sine 55. 6.55. I don't know. I think it specifies on the quiz, but so the number of decimal places, but vertical component was 6.55. So if it had said horizontal, we just would have needed to do cosine. Any questions on that? Just read carefully. My only suggestion there. Sketch and find the horizontal and vertical components for this vector. Okay, so here's what's going to mess somebody up. What is this saying? Okay. Off of which one? The 32 is here or here? It starts on the first one, guys. Yes, it's here, 32. Okay, it's off of north towards the west. So how are we going to find it? So we drew it and we can label it 100 miles per hour. Okay, that's part of the question. But then it says find the horizontal and vertical components. What's the trick? Can we use 32? No. No, what do we have to do? Good job. So we add 90 and get 122, and then we just type 100 cosine 122. What mode are we in? Still in degrees. Can anybody tell me what decimals they get for those? Should be a negative and then a positive, right? (100 cosine 122, 100 sine 122). Got negative 53 and 84.8 roughly. Anybody? Yes? Okay. Any questions on that one? All right, then they get a little more complicated. It says we should go to worksheet 9.5 and look at 22 and 23. 9.5a. All right. You have a question. You're given the ordered pairs. Do you remember doing this? The vector goes from 2, -10, down here somewhere. That's A, to B at 3, -5. So it goes from A to B. Does anybody remember the rule for finding the components given the ordered pairs? How did it get from 2 to 3? Okay, it went to the right one, but same thing, right? It increased by 1. And from -10 to -5? Yes. So the rule, though, if you do it by subtraction, it's x2 minus x1 and y2 minus y1. Okay? I always just do it in my head, but it has to be going from A to B is going to the right and up, so they need to be positive. All right, then it says find the magnitude. It just wants magnitude here. How do we find magnitude of this vector? Guys, how do you find magnitude always? Yes, it's saying it went over 1 and up 5. So we want the length of the vector. So it's 1 squared plus 5 squared. So the square root of 26 or some decimal. Everybody good on what magnitude is? Okay, 23 says to take 2 times q minus p, and you're given these. You remember how easy these are? So it's 2 times -2, -3, and then it says minus p, which is 4, 0. So if I double these, I'd have -4 and -6. And then I'm supposed to subtract these or add the opposite. So final answer, -8, -6. Way too fast. Everybody remember this? Easy, gonna get that one right? Just watch your signs and stuff. I didn't make a mistake, did I? Okay. I think that's it for that learning target, but then there's another vector learning target. This is the one when you have to add 2 vectors together, okay? And then you also have to talk about bearings and finding the angle at the end and all that good stuff. Okay. The first question is off of worksheet 9A. The question on the quiz looks just like this. You're just going to add them together. Does anybody remember how easy this was to do? What did you do? What are the components for A and what are the components for B? Oh. And then B over here would be 2.8 cosine of 50 and 2.8 sine of 50. But then what did we do? Yes, you just add these two together and get a component, and you add these two together and get a component. And then you have to find the magnitude and direction when we're all done here. So what mode are we still in? Yep. Whole quiz so far, we've been okay in degrees, right? Anybody get 2.68 for the first one? Anybody get 5.43 for the second one? Anybody not getting those? Okay, so there's the components. How do we find magnitude and direction? Pythagorean theorem always gives us magnitude. Anybody get an answer? Anybody get that or not? Did I type something wrong? Okay, there's the magnitude. How do we do the direction? This vector right here, what angle is it making? It went over 2.68 and up 5.43. How do we find the angle? Inverse tangent y over x from the components. I got 63.7 degrees. Do I need to do anything crazy with that? Like add 180 or something? No, it's quadrant 1, and the question says the direction relative to the horizontal. Is this off of the positive x-axis? So we're all good. We're done. This is direction. So components were there, magnitude, direction. Any questions on that one? Okay. This is 9A, number 3. Could you change this to 160 degrees because it's more like the quiz? Right here, it says constant angle of 60. The quiz has one that's in quadrant 2, so change it to 160, okay? I'm trying to help you out and do one more like the quiz. This is number 3 on worksheet 9A. Okay, a constant, this time there's no picture, I don't think. A constant force of 15 newtons is being applied at 30 degrees, okay? So we would just have for the components what? 15 cosine of 30 and 15 sine of 30. We're still in degrees, right? Okay, then it says, at the same time, a constant force of 25 newtons is applied at 160 degrees. So that is going off the positive x-axis all the way over here. And it's 25 newtons, 160 degrees. So same thing. Remember, we changed the original question. Okay, now what? So 15 cosine of 30 plus 25 cosine of 160. Negative 10.5, anybody? Does that make sense that it would be going to the left? Because this one was stronger, right? And then 15 sine of 30 plus 25 sine of 160, 16.05. On the quiz, guys, be real careful. You know, type stuff twice or go back after you're done and check. It's so easy to type something wrong, right? And then you're messed up for the whole rest of the problem. And I can't always figure out what you did wrong. We need magnitude and direction now. Magnitude is easy. We just do what? Pythagorean theorem. Either leave the negative off, though, or put parentheses. Around 19.2, anybody? Okay, that's the newtons that it's going to end up being because they were kind of canceling each other out. Does that make sense? They were working against each other. But we need to figure out the angle. So we do inverse tangent. Now, where did this wind up? Our resultant right here was in quadrant what? 2. Okay, got to make sure that that coincides with our answer here. So we're going to put y over x. And do inverse tangent of y over x. And I got negative 56.8 degrees. Is that in quadrant 2? Negative 58.6, 56.8. What do we have to do when it's not in the right quadrant? Just add 180, yep. So 123.2 degrees. Does that make sense, guys? If it was pulling 30 degrees this way and 160 this way, it's going to wind up somewhere in the middle of those. 123 seem okay? All right. Then there's an airplane question. The thing about the airplane question, I made it as easy as I could, guys. The plane is either going north, south, east, or west. And the wind, I gave you a picture, and the wind is either pushing it northeast, southwest, southeast, north, whatever I left off. So what angle is it going to be? 45, yes? Okay, some kind of a multiple of 45 because it's straight up northeast, southwest, whatever. Okay, so this one says an airplane is heading due south. So the plane is trying to fly straight south at 450 miles per hour. And there is a wind blowing from southwest. Okay, so this is what it would look like on your picture. Southwest is over here, right? Okay, it would look like this. So what is that telling you? It is slowing it down. It's also, we're going to use this angle in here, okay? We're going to push it, first quadrant is where the vector is going to be. All right. Everyone gets why I have 45 degrees? Because it says exactly southwest or northeast or northwest, okay? I didn't make you do a vector component for this. Or, I mean, a compass bearing. Okay, now what? This one was 85. How do we do the components for the plane? If you wanted, you could do 450 cosine of how many degrees? 270 and 450 sine of 270. What is it just going to end up? It's going straight down 450, okay? You can type it, but that's what you're going to get. All right, what about the wind? What about the wind? 85 cosine of 45, 85 sine of 45. Now, if it had been over here in this quadrant, we would have had to use 135, right? If it had been down here, it would have been 225. Some multiple of 45, put it in the right quadrant. Okay, go ahead and add these to figure out what the components are of the actual flight path. Guys, I made this as easy as I could, so please be doing this with us, or be awake at least. Nolan. Anybody get the components? Yeah. No, I did that one. I got that too. Now what? How do we find the speed of the plane? Also called what? Magnitude. 60.1 squared plus, yeah, I would just leave it positive and then I wouldn't need parentheses, but 60.1 squared plus 389.9 squared, square root. I did get 394.5 miles per hour. Does it make sense that the plane is not going 450? Because the wind was blowing pretty hard the other direction, right? Yes. Great question. What does your calculator have to be in, guys? We did this as 45 degrees. Does that make sense? Yes. I added it to this. Okay, this is my result after adding it. That's why it came out this. The cosine and sine of 45, yes, we'll give you the same thing. All right. Angle. The question asks, how many degrees off course will the plane end up flying? So this is what we're going to do. Inverse tangent of the components, which were negative 389.9 and 60.1. Inverse tangent, negative 389.9 divided by 60.1. Okay, I got negative 81.2 degrees. That's where the plane is winding up. Right here at negative 81.2. Is that in the right quadrant? It is in the right quadrant. Okay. Is that how far off course it is, though? How do we find out how far off course it was? It wanted to fly here. Yeah, can we just do like 90 minus 81.2 or add 90 to the negative? It's about 8.8 degrees off course. So that's going to take some thinking on your part because it's different in each quadrant how you find it, but we just want to know this little angle, how far off, because it wanted to go straight south. Okay, for more practice on that, okay, this one is on 9A. It's number 4. Okay, and it's keyed in the Google Classroom, but I'm going to keep going for right now. Are we good? We have 9.1 and 9.2 left to go over. 9.1 is polar. Okay, you gotta tell me how fast I can go here. This is 9.5a. Okay, so negative 120, I would give you graph paper that had degrees on it. Negative 120 would be positive 240, yes? I'm just doing this number 13, just as it was highlighted here. And then go out 4, 1, 2, 3, 4. Okay, I don't remember if it's degrees or radians, but I give you labeled graph paper and you have to plot 3 points. That's it, and label them. So this one was Y. Make sure you label them because I gave you one graph and you have to put 3 points on it. Okay, so if I did this W, you'd go around to 210 and then back up 0.5 would be over here and label it W. You get what I'm saying, guys? You have to graph 3. Do you need more practice? All right, I'm very nervous about this question. There is either a what or a what. What are the 2 kinds of graphs I said you had to remember in polar? It's either a line or a circle. Do you remember which one made which?
So R makes the line.
R equals 7 means it has a radius of 7. I'm going to change that, make it like R equals 3. If it said R equals 3, it would be this graph. Okay? If it said theta equals negative 60, well, it's this line, and it would just be a line, right? Okay, so what you have to know is that theta equals is a line, R equals is a circle. And then you just have to look at the graph. What is the radius or the angle? It is a multiple choice question. I give you a graph, you have to pick out the right equation. You can't use your calculator though, it isn't going to help you. If you got an R equals, it would do it for you, but just know the difference. Should be easy, quick question, okay? If you remember that. Everybody good? R equals means it has a radius, so it's a circle. Okay, guys? All right. 4 names for this point. Remember I said this one is also multiple choice? I gave you 4 names and you have to pick which one is wrong, okay? Can you give me some right ones, Kelsey? Oh, nice. She didn't even go with an easy one. Avon? Take 180. No, take 180 off, so it would be 60. If you went positive 60, then you would back up. Anybody come up with the negative negative? If you went, how would you get to this same spot over here going negative? Okay, we good on that? So this is more plotting of points. They're in radians. Do you need me to do this one? I'll come back to it if I have. I'm not going to have time. Just kidding. Distance between. Anybody remember this? Distance between. Formula is on your pink sheet. Find it? It's law of cosines. Yes. It would be, for number 21, it would be negative 1 squared plus 6 squared minus 2 times negative 1 times 6 times the cosine of, and you subtract these, negative 45 minus 270. What mode should I be in? Yes, because the angle is in degrees. Okay, I'm going to go ahead and just keep going. Yes? Okay, that's a typing question. You just got to remember that you have the formula. All right, then we did yesterday This first one you can do on your calculator. This is where you need to switch your calculator to radians, okay? If you're graphing this, it's actually a matching question, I think, or something. But this would be a flower with 3 petals. I think it looks like this. It goes out to 4, but something. You would just do it on your calculator. Okay, this is what we did yesterday, though, if you were gone. How do you find the rectangular coordinates if you know an r and a theta? Grab your pink sheets. It's 6 cosine 7 pi over 4 and 6 sine 7 pi over 4. You go to the pink sheet. 7 pi over 4 cosine is square root of 2 over 2. Sine is negative square root of 2 over 2. So when you multiply those, you'll get 3 square roots of 2 and negative 3 square roots of 2. If it is multiple choice, it's probably going to be exact. If it's free response, I don't care if you type it in your calculator and get a decimal, but what mode would you have to be in? Yes. Okay, this question says we have over here at negative 3, negative 3. How do we find the r and the theta? It's so totally related. Yes, if we do Pythagorean theorem, it comes out square root of 18 or 3 square roots of 2. I really don't care. Or you could give me a decimal. I don't remember if it's multiple choice or not. And then if I do inverse tangent, it thinks I'm in the first quadrant. Yeah, I would need to add 180. It would actually be an exact answer of 5 pi over 4 because it's a 45-45, but I'm okay with a decimal as well. Okay, so when you're changing from rectangular to polar, you need Pythagorean theorem and inverse tangent. All right, these are a couple more examples off 9b. Again, those are keyed. Okay, anybody remember this from yesterday? If you don't, if you missed yesterday, this is a concept you're going to get totally wrong and not have any clue. And it's simply following a recipe, okay? Simply following a recipe on the card, but you got to watch the video from yesterday. Any questions? All right, so we ran out of time, but I'm going to go ahead and record this real quick. If this was an x and a y, it's over 5 and down 5 square roots of 3. That's a 30, 60, 90. If you did Pythagorean theorem, you would get 10. So that limits us to this choice. And 2 pi over 3 is not in the right quadrant. So it would be this one. 5 pi over 3 puts us in the right quadrant. So without too much extra work, you should be able to figure that one out. This is an r and a theta. So to find the coordinates, you could just do 3 cosine 5 pi over 6 and 3 sine 5 pi over 6. I would do exact, but it doesn't say you have to. So you could just type them in your calculator, but just make sure you're in radians. So at 5 pi over 6, the coordinate is negative square root of 3 over 2 and positive 1/2, I think. And you're multiplying those both by 3 to get negative 3 square root of 3 over 2 and positive 3/2. All right. Then the last learning target or the last concept on the quiz is this, and remember this is all over your pink reference sheet. Your goal is to have a 1 down here. So for this particular example, this is a pretty easy one. The 1 is already there. So the formula is R equals ED, it's right off the sheet, over 1 minus E sine theta. So E is 2. It's always positive. It says at the top, E is always greater than 0. So E is 2. If the eccentricity is 2, down underneath there, it says eccentricity greater than 1 is a hyperbola. And if E is 2, and the top is 14 up here, E is 2, that makes D equal to 7. And on the reference sheet, it says the directrix for this particular equation is y equals negative d, so you'd have y equals negative 7. Those are the 3 things you have to know for the quiz. The one on the quiz, though, starts out like this. It doesn't have a 1, and it isn't a nice fraction, so I changed this to a 3 for my example. Because it isn't nice on the quiz, you would divide everything by 3 here, so the top would become 8/3. If you divide this by 3 and this by 3, you'd end up with 1 plus 4/3 cosine theta. So again, this is equal to ED over 1 plus E cosine theta. Pink sheet, that's where I got that. So this makes E 4/3. And E greater than 1, it says right on your sheet, is a hyperbola. And then the equation of the directrix, when it has 1 plus E cosine theta down here, says it's x equals D. But we have to figure out what D is. Right up here, it says 8/3 equals ED. And we know 4/3 is E. So for those of you who have trouble with fractions, to get rid of 4/3, we need to do the reciprocal to both sides. So this will be nothing, just 1. And over here, we get 24 over 12, or 2. So D is just 2, so we have x equals 2. And it's positive because the little pink sheet said when it has 1 plus E cosine that the directrix is x equals D, positive. E and D are always positive by definition. All right. So that's it. If I go back, we skipped, what did we skip here? Some more stuff on this. I could put the answer for this up here real quick, just so you had it. Again, this one is in degrees. Make sure you're in degrees. I got 6.77 for the distance. Okay. This is just more plotting. If I did this one real quick, pi over 3 back 2 would be here. Negative pi over 6 would be to this one, back 4 be here. Negative pi over 4 is here, out 3. And 7 pi over 6 is around to here and out 1. There's the answers for that one. All right, I think I covered quite a bit. Other suggested questions, the answers are on Google Classroom. All right, so be ready for the quiz.